start by getting a blank project with C++ up and running. I'll call it Rogue Mass Demo. So once in the editor, go to Plugins, search for Mass, and we're just going to enable all these Mass plugins here. So we've got Mass AI, Crowd, Entity, and Gameplay. We'll create a new level to use. We'll create a new one. We'll do a basic one. And then we'll exit. And then just in the C++, we're just gonna come to our source and our project and our build. We want to add the mass. So the first one's mass entity. Mass common. Mass movement. At some point we'll be using all these, but representation. And the last one's navigation. That's good. So since I've added plugins to the project, I'm going to rebuild. So I'm going to close this off. Come to the directory of my project, delete the SLN, immediate, and binaries. And rebuild. So for this first video, I just want to show spawning mass entities. So there's a couple of steps in the code, there's a couple of steps in the editor. I'm going to build a queue system for spawning. So this won't really matter unless you're spawning a heap of stuff at once, but basically what I want to do is protect against spawning too much stuff per frame. So if you're just spawning, like you're clicking on a building and click build and, an entity pops out and it's a unit or something, you won't need this sort of thing. But if you're doing something like, I don't know, something that's real fast, like ore on a conveyor belt or something like that, and it's just going like pumping out, spawning entities mass fast, then this will probably be beneficial so you don't overdo it per frame. So we're going to start by creating a subsystem. I'm going to call it the Rogue, let's call it shared subsystem. It's going to inherit from a world subsystem. And I'll put that into subsystems. And then the other thing I'm going to want is a processor. So I'm going to, what do I know? Rogue entity spawn processor. Should have specified that. And this will inherit from mass processor. And put this into, I forgot to do the bloody public private thing. I'm going to have to fix that. Processes. I'm just going to fix this subsystem to move it into these public private things. So we're going to need a way to pass in an entity template or its entity configuration. So I'm going to do that through developer settings. So I'm going to create that. I'm going to put that in a data folder. And in here, create the header. And this will be, I'm going to make it a soft object pointer. It doesn't need to be soft object pointer, but if you do make it a soft object pointer, just remember you'll have to load it. And that is what we'll do. And this is a config asset, and that will require the header for mass entity config asset. So forward declare that. And we'll just call this the entity config. So we'll probably have more of these in the future, but this will do for now. And we'll have to remember to assign that once we get into the editor. So in here, we want our initialization and deinitialization functions. And this is where we'll load that data. So in here, we'll get our check if we actually remembered to assign that. So it'd be settings, dot entity config, and we can just check is null. Change this to not. So if it's not null, we want to load it. And what we'll do, get this, and create a variable. Oh, actually, that's what I forgot in the developer settings. Got the header info. Go do that quickly. So in here, we need to define which config it's going to save into. I'm going to do game. And this will just add a display name, so that's what will come up in as the project settings as. And we'll call that, oh, actually no, sorry, it's brackets then, display name. Rogue demo settings, there we go. Where was I was back here, wasn't I? So U property, mass entity config asset, and we'll call this the entity config, same as the thing. We include our forward declaration for that. So that'll load that config if it exists on startup. We'll come to protected, and we're going to override the world begin play. I think it is. Yeah, on world begin play. So this is just begin play for a subsystem, or a world subsystem. And in here, we want to check that our entity config was assigned. So we just want to, and then if that's okay, then we want to create our entity template. And we'll do that by creating another variable. And this will be an f mass entity template. And we'll need to, we actually want to include the mass entity template.h. So pointer, and this will be entity template. So from the config, we'll make a template, is how it works. But this is happening on init because it's going to load the data, and then this is going to happen on world begin play when this has already occurred. So that's our template. Now the spawn process is going to handle spawns, but it's going to palm it off to this subsystem. And it very much depends on how your game's going to handle spawning entities, how you want to do it. But I'm going to do it this way because I think it's the best. It sort of covers most of the options. But even if you are clicking on a building and clicking building, spitting out an entity, this system will still work. It's just the building will do the enqueue to the subsystem rather than having a processor spawn them. But what I'll do for this demo is I'll have the the entity spawn processor there spawn entities sort of just in chunks or, over time, but they only live for a certain amount of time, just as an example. This would be in queue spawn request. And this is going to take some data. So we'll just come in here, we'll create, I'll create it through here, just empty or something. So this will be just our data types. The generic structs we'll put in here. Don't need the class. We will need a constructor generated. And our first struct will just be a frogue spawn request. You can spawn them directly, but this will do that queue system I was talking about, so you can put limits on it. And this spawn request is what will sit in the queue and tell us what we need to spawn and how many and its details. So for this, I think we'll do an enum as well for our types, because we might have more types in the future. And the first one will just be, just to call an entity for now, and then we'll add more types later. So in here, we want to have, we don't need U property type. Yeah, I'm going to put in here just an int for a remaining count, and that'll be how many to spawn. Actually, we'll just call it count, because then, so when we send a spawn request, we can say, I want to spawn 100 of these, like a stack, and then the spawn system will, if like 100's too many to spawn in a frame, then you can spread it out over multiple frames. So back in our subsystem, we can pass that in. And we'll need somewhere to store them when they come in. So now we want something that processes these, and we could have made this subsystem tickable. There is a world subsystem tickable. We've probably seen when I was creating this, but it's sort of case dependent. But I'm just going to use a timer. So I'm going to set up a timer now for that. I might make the timer enable, disable, public, and then you can sort of like turn spawns off and on. I'll just build those. So in here we'll need a world reference to get the timer manager, and the subsystem has that, so can do. And there's a function already on here called get world ref. That's in the parent class of all subsystems or world subsystems. And then we'll just check that's valid. So it'll be is valid. I will check if it's the timer's already running. So if and we'll need a handle. Write that down here. If it's not active, then we'll start it. And we'll call process pending spawns. And the rate we'll just put in 0.1 and it will loop until we stop it. Oh, not loop, true. And then we'll grab all of this into our stop. And then the stop, we don't need to check if it's running, we can just clear it. So, and then in our process pending spawns, we want to start going through our spawn request lists in reverse. So we're going to do it for, the reason we're going in reverse is because we'll remove that pending spawn when it's processed. Now we're going to need some stuff for this. We're going to need a reference to the entity manager in the mass entity system, and we're going to need access to the mass spawner subsystem. So I'm going to make those actual references that we set up in initialize, so we're not doing it over and over. So the first one's the F mass entity manager. And that's how you access any entities in the world through mass. And then the other one is the UMass spawner subsystem. And we'll just add a forward declaration for that, like so. And then we'll assign those here. And in order to get the mass entity manager, we need to get that through the mass entity subsystem. Actually, we'll do that in world begin play, because we'll have a world reference that we'll need. So go in world. Mass entity subsystem, and we're going to include the H. And we're going to have to change this now. Oh, yeah, if the config's not set, we probably want to bust out of everything, so we can leave that as is. Because if the entity config's not set, it's not going to get down to here. So that's okay. Now we want to assign that entity manager. Assign it. And we can get the entity. Oh, yep. We need this to be a pointer. And we want this to be the mutable energy manager. And then for the spawner manager, we can do same here. Copy this. What do I call it? Spawner subsystem. And this will be the UMass spawner subsystem. And we'd have to make sure we check that they're valid when we go to use them, which is what we're going to do right at the start of this. So if and now we're going to need our settings again. And we're going to want to build a list of entities that we're just spawning this tick. So when you spawn an entity, it comes back with that mass entity handle, which is the main thing you want to pass around when you're referencing entities. And then we'll need a setting for how many we want to spawn for this tick. And I might put that in the settings. Sounds good. Create a reference to that one, the one that we're up to. It'll be we need to cap it at our, like so it doesn't go over the spawn this tick amount, but it also needs spread across maybe multiple pending spawns. So what we're going to do is we're going to check we're going to take the smallest amount of either the request. It's either going to be the count remaining or the spawn this tick. I'm just going to put a check in here for 0 somehow. Somehow there's a spawn request in there with 0 count. We don't want to do it, so we'll just skip it. Or, actually, we should, before we continue, should remove it. We want to spawn an entity. So we're going to create another array. This will be all the entities spawned in this tick. And then this one that we're going to create now will be the entity spawn from this pending spawn. So we'll call it request entities. And then we'll get our mass spawner subsystem. Oh, we need to include this. There we go. So in here we need the template. So we're going to have to choose the template and use it. So I'm just going to put a little switch in here. All our cases, all heaps of them, look at them all. We're going to use this to grab the template. So we've only got one at the moment. So probably need to dereference that maybe. So no, that's good. We want to pass in, so you can see there the number to spawn. So that is our this batch amount, and then we need to pass in an array to pass them out, which is our request entities. So that will spawn based on that config, which we'll set up in the editor later. You're probably asking yourself, where the hell does this spawn now? And that's the thing. I'm guessing it's at 000, but I don't know. So we'll need to do some sort of post spawning. We'll call that here. So it's a tease. We can either assume the position or use something as a reference, or probably the best bet would be to include a world position in the spawn request. So like we were saying about before, if you're requesting from a building, like a build thing, then the building system can assign the requested spawn position or positions. It might be an array of how many you want to spawn in, or like a grid pattern or something. That's what we'll include in the spawn request. So I'll put in here for now. I'm just going to spawn them at 000, so that'll work just fine. I don't need to set it. But in order to set the transform on an entity, it will need to have the transform fragment. So for now, we're just going to assume that it has it. So if we go transform fragment, there's one built into mass and the mass common fragments. That include did. And then to get a fragment of an entity, actually, sorry, this will need to be in a loop, because we need to do this for every single entity in this request. We'll go through the entity manager. We'll request a fragment data pointer. And the fragment we're after is our transform fragment. And it's for this entity. And sorry, this is. So on the transform fragment, it's just like your normal transform, but in a fragment form, in a mass fragment. And you can see here we can get the transform, we can set the transform, and we can get mutable transform. So you can see just the get transform is a const, so you won't be able to modify it, but you can read it. We want the mutable. So if we say transform fragment, get mutable transform, and then we can just set the location. And you can set the rotation and scale and all that there as well if you need to. And the other thing you could do is, because the spawn request has the type, you can then set, you can have we can just, go through and do like a switch again on our type. Even though we've only got one at the moment, but you can then configure any specific stuff for the different entity types as you get more. Anyway, back to our processing of spawned entities. So we want to update our count now. So on the request, and then we will also want to update our spawn this tick so that when we go to the next request, we're not going over that. And then we want to check if we've spawned everything for this request. So then we want to do this. And if it's less than our budget, we want to return. So we'll come back next frame and do the rest. We need to create a mass fragment for our entity so we can store some data on it. So let's go to data and create another blank class. And I'm just putting all the fragments in this one file, but you can do it individually or you can do it in headers or different things. It all depends how you want to lay it out. Fragments are generally pretty small though, so that's how I like to do it. And you just want to inherit from fmass fragment. And that's going to include the entity element types, H. We'll have a few settings. So now to set up a processor. We'll need to override some functions in here. So the first one is the config queries. And then the other one is the actual execute. For the config queries, we'll need a fmass query, entity query, I believe. Yeah. Call it whatever you want. It's just a variable name there. So in our constructor now, we'll want to register that query. You used to do this in the actual query thing. I found that I could only get it to work after 5.6 by doing it in the constructor here for some reason. In the constructors where you set your processing phase or your execution order. You can see all the different ones there. Yep. And now onto our query. So our entity query here. This is where you add. So the query is what defines what gets executed in this processor. So we're going to add requirement, and we're going to include our fragment that we just created. So it's just included our rogue fragments.h. And now that we've defined that, hey, we want to use this fragment, it wants to know whether we want to just have read or write access. Now you need to know what you're going to be doing in your processor. So in this, I know I am going to update the time to live with delta time from the context. So I will need write access. And it's really important to think about that, because if you only need to read, then you can really optimize how fast this thing can push it through. So what was this? Oh, here we go. So fragment access is read write for this one. You can use tags to define it down. So if I only wanted to, say I had multiple entity types, they all have this rogue entity. This is a generic entity fragment, say, and that's on all the types, but I only want to spawn it onto my one type. I can put a tag on that one type and then filter by that tag, and you just do entity requirement add tag requirement. We'll get to that in a later time. So just be aware that's how you would filter between sort of the same types, but for different sets for processors. And then we just need to register with the processor. Right, so now to iterate over entities, we get that query, and we do a for each entity chunk. The chunk will be a subset of the entities that configure queries returns. Say there's thousands of entities that are coming back. A chunk might have a certain size, say it's 1024 or something in this chunk, and then it will run everything over this chunk, and then the other chunks will be parallelized at the same time. There we go, that's our loop over our entities. So you can set up stuff outside the for each loop. All right, so inside the entity chunk now, to access the fragment, again, you can set this up to be const or by read only or write access. So the write access way is a TRA view. What this is going to return is all the entity fragments that we have. So we'll just call this and this will use the sub context. And then you'll have some getters here. So you have the get fragment view, which is what gives you the const version, so the read-only version, and then there's the get mutable. Can't see it. Oh, there it is. For the type here, so it's our fragment type. And then that subcontext, we can get a number of things from there. So I'm going to get the number of entities that we're dealing with in this batch. And then that allows us to do loop on those. So number of entities. Now, if we wanted to access our actual mass entity handle, we can do that. And we can use the get the index just to get through the subcontext, get an entity with that index, and it will return our mass entity handle. That's kind of a standard setup that I try and run. You just got those references there each time. We want to also get the specific entity fragment for this entity. We'll get the reference to this. We just get the index out of here. That's why this can be const, because we're not actually editing this array. The actual structs inside that array are editable. So now we can just straight up read the entity fragment and assign data. So I'm going to do entity fragment. We can check if the time to live. So now to destroy the entity, we need to defer that command. So we're going to do, in our subcontext, there's a defer, and that'll just execute this command, I think, after this loop. So we may not need to put that in reverse, but the can't hurt anyway. And then in the defer, there's a whole bunch of commands, but so you can add tags, you can even add fragments. Yeah, we want to destroy entity. You could have different times. I'm just going to say, I don't know, 10 seconds. You could make this a setting in the dev settings if you wanted to. To update that time to live, so let's just come into our pending spawns, configure spawns. Let's do it in here. So we're going to do a similar thing to this. We're just going to get a different fragment. So this will be the fragment. Put the include for our fragments. This go in here. On our entity fragment, we're going to set time to live to be the requests last time to live. One thing we need to do is we need to start the spawn manager. So we'll put this down here. And then in the spawn manager, we'll change this. Instead of calling this process pending spawn request straight away, I'm just going to add in a, let's just call it. And then we'll add another here, spawn entities. And this is what you'd move somewhere else. Like, you know, this code will get called from wherever you like click the spawn on entities or you're running something frequently. I mean, so let's just call process pending and spawn entities. So then my spawn entities will get processed after the, you know, like next frame. They'll be in this process spawn entity. So this would be spawn manager now. And then inside the spawn manager, we want to, the spawn entity, sorry, we want to calculate a position. But I'm not going to do that. I'm just going to spawn at 0 for this time being, and then we'll generate a request. And then for the spawn request, we'd set the type and we'd set the position. We need to set that 10, which is already set as well. And then if this was on somewhere else other than this shared subsystem, you get a reference to the subsystem through the world, and then you'd just call the in-queue spawn request. I forgot to put the count in here. Spawn request count equals 1. I've got a not in there. Alright. So if it is valid, I could probably leave that actually and do a return. Okay. This is confusing as shit, so I'm gonna, if it's not null, do this. I think I just forgot the public there. Actually, I think these don't like to be properties. That's what's going on. So I might take that off. Looks like we're missing our developer settings in the build. Almost third time's a charm. I'm confident I'm going to load up this time. Alright, I'm just going to change this to my loads up with my level next time. First thing we need to do is create that config, so I'm just going to put it in here. And it's actually a data asset, so data asset and just search for that, not rogue, mass entity config asset. And we have our entity here and we can add traits. So I didn't cover creating traits. The traits are just a collection of fragments, so you can create a trait that has a whole bunch of fragments in it that you want to add to, that entity. It's a way of grouping them together, but you can add individual fragments through this assorted fragments. Yeah, assorted fragments. And then in here, you can add individual fragments. So we can search for our rogue entity fragment and add that. Or we also want to add the generic transform fragment, the bit one built into mass is what we're accessing. Debug visualization is what we want. And then we're just going to give it a mesh of a cylinder. I'll do it. It's going to be huge. Alright. Save that config and then assign it to our developer settings. So you should have your rogue mass demo settings. Assign the config there. Now if we give it a test run, alright, we have our entities spawning, but we can't really see much because they're all on top of each other. There is several debugging tools, so if we go to Tools, Debug, and there should be a mass debugger. We can see here. There we go. You have to just choose the environment. There we go. And then we can see our entities. So you can see our processes there. So there's our archetype, which is our config. The other way you can debug your entity is in the actual entity debugger. There's a mass option there, so numpad 5, which is again not going to show us much because they're all on top of each other. No, there's not much to look at, but we've done the hard bit. This is the boilerplate. We've got some entities spawning, so next time we'll look at moving around and doing something more exciting. If you're interested in learning mass further, I've got an example project that's a bit more advanced with detailed documentation that covers more advanced concepts of mass, and that's available from a public Git that's linked in the description. Thanks for watching, and thanks to all my Patreons that have made this mass series possible, including the demo project. If this is helping you out, if this series is helping you out, consider becoming a Patreon, and I'll see you in the next video.